Batterie 60%. Connecté à MICOLS HP.
Hello, all. My sound is okay?
Yes.
Okay, good. So let's keep going. This is, I remind you, the last class we're having online. The other one should be in person. I will see how it goes. It depends what the class setup is and make experiments. I couldn't go there and look at how things are going to work out, but yeah, I like this with doing things with slides and adding some comments or stuff. So perhaps I'm going to be able to still have classes that are sort of in person, but also yeah, on Zoom, but I can't guarantee anything. So yeah, default is please come to the class in person next week. All right. Any questions before we go on? Right. So program for today is finishing chapter 4, and probably I'm just going to go back on the solutions for chapter 3 exercises just to make sure that everybody got them right, and then we can start maybe some exercises on chapter 4. So just to familiarize everybody with everything. Okay, so where were we? Yeah, I think we're, yeah, okay. So we had just seen negative externalities, right? So yeah, positive externalities are just the opposite of negative externalities. So it's when the action of somebody has a positive impact on other people. So that person doesn't internalize the fact that this transaction or this production or this consumption or whatever you want to model it, this economic decision that's been taken by a consumer and a producer is taken without considering this positive external benefit. So here we label this external benefit for an external positive externality. So essentially, we're never going to say that external, even if an external benefit is something that reduces the cost to some other firm, for instance, we're not going to say, oh, it reduces the cost for that firm because it's really something that's external to it. So we're just going to add it to the sort of marginal willingness to pay of the private person. So we just add, so we add to the positive aspects or add to the costs if it's a negative externality. So you're going to see what I mean by this.
Sir, I have a question.
Oh yeah, I just saw last the last recording that isn't working. I don't know why. I haven't had time to check it, but yeah, was it your question?
No. I have another question.
Okay.
Because I just want to make sure that I'm grasping and I'm understanding, all the concepts in general. For example, on this slide, you're saying social benefit is equal to private benefit plus external benefit.
Yeah.
So everything is in parentheses of Q. So everything is on quantity, right?
Yeah.
So will it ever be on price, or will it always be on quantity no matter what?
So I show this way. I can show it next slide. So it is because in all the graphs that we're going to have, we're just always going to have price here and quantity here. So essentially, they're all functions of quantity that gives you some price. So
Okay.
Yeah. But yeah, you could model it in some other ways, but I think this just sticking to the same concept every time is positive.
No, exactly. I know it might seem very stupid like question, but I just wanted to make sure that it would stay, for example, on constant, meaning always on quantity.
Yeah, no, it's not a stupid question. If it were a stupid question, I would exclude you from the class. No, I'm kidding. No, it's a perfectly nice question. And the thing is, I added this. So yeah, in the book, I think they really don't say whether it's a function of Q or whatever, but I think it makes things clear. You could just drop Q. But yeah, it makes things more abstract. So I like to say what's a function of what. All right. So yeah. So social benefit. Yeah. So social benefit, or the total social benefit, is the sum of the private benefit to the buyer, so to the consumer that actually pays for it, and then the external benefit to the person that doesn't have a say in the transaction, but then you really must take both into account to take a proper decision as to how much to supply to the market, for instance. And then you take the derivative of all these things, or if you're not familiar with calculus, just think you look at increasing at how much one extra unit increases each, and you get the marginal. So marginal social benefit is how much an extra unit adds to the social benefit. Marginal private benefit is how much an extra unit adds to the private benefit, and same thing for the marginal external benefit. Yeah. So yeah, all of these are areas in the graphs in the following graphs, whereas all of these are curves or straight lines, since I'm always getting new straight lines. Yeah, so this is what I mean by whatever you have an externality, we're only going to be adding two lines. So if I have a external cost, then I'm just going to add to this private cost some external cost like this, so that this would be, for instance, the sum of the costs. So private cost plus external cost. Same if I have something positive that's coming out of it, then it's going to be private benefit plus the external benefit, which gives you the marginal social benefit here, MSB. Yeah, I didn't write MSB of Q, but I could have written that. All right, and here so I still get so yeah. So just at the private equilibrium or the competitive equilibrium, then consumers pay as long as the price is is below what they're ready to pay themselves. And producers produce as long as the market price is above the marginal cost. So the competitive equilibrium is when the demand curve, which is the marginal private benefit, crosses the marginal cost or the supply curve. But obviously that's not the optimum, so because there is this external benefit. So what should be the real price of producing this? Well, it should be higher, because the society in general should be ready to pay more, because there's this private benefit for private people and this external benefit too. So the quantity should be actually higher. So the QS is the socially efficient quantity, should be higher than the private quantity. And how do you can measure how bad it is that this is not produced. And here it's deadweight loss. That looks more like the deadweight loss you might be familiar with when we have something like taxes. So when we have taxes, it's like the opposite. So you have that the market equilibrium is here, and then you add a tax that's like this. And then since the quantity consumed is lower than the equilibrium quantity, then you get this deadweight loss. So this is exactly, no, not exactly, but it's similar. It's akin to the fact that society would like to be here, but there is something that we don't take into account that makes us produce less. And deadweight loss is always the same. It's the difference between the demand and the supply. So here the social the marginal social benefit and the marginal cost. So yeah, so that's here. So if you want an interpretation, what's going on is, say for instance at Q star, so people are ready to pay P star, and producers are ready to pay to receive P star. But there is the fact that, so the marginal cost of producing the good is P star, but the marginal benefit, the social marginal benefit, is not P star. It's P star plus this higher social benefit there. And for all these extra units, then the marginal social benefit is always higher than the marginal cost. So these units should be produced, and they don't get produced. As we're going to see, this is a bit linked to another concept, which we call public goods, meaning that here there's one private person who bought the good, but the good has some other positive impact on other people. So a similar concept is going to be when we introduce public goods. So does that make sense? So every time the deadweight loss is, yeah, for, could give you some summary. So for positive externality, the deadweight loss is the area below the MSC and above the marginal private cost. And here there's just the marginal private cost, because I didn't add the marginal social cost. All right, so does that make sense? Did I go too fast? All right, so stop me if you have any issue later with that. Sorry. All right, so consequence, just a summary of what we've been saying. So the production of the good, if there's a positive externality, so affects positively other people. So consumers who buy the good, they just pay for what they get themselves, and they don't care about this positive impact. So they don't take their decisions don't capture the full benefits of production. So the marginal social benefit is above the marginal private benefit all the time. And the market equilibrium is obviously just between private people. So marginal private benefit equals marginal private cost. But that's not what should be efficiently supplied. So the good is provided if the market is uncontrolled or unregulated, or if there's no incentive given to people to consume more or to producers to produce more. Yeah, so it would be, society would be better off if the society would find a way to compensate individuals to produce goods with positive, who produce goods with positive externality, or to encourage consumers to buy more of it. Yeah, as I've been saying, so public goods are rated to positive externalities. Now, in this class, we're not going to have too much of goods with positive externalities, because most of what we deal with is nature and pollution tends to be a negative externality. So yeah, I gave an example, an exercise with positive externality last midterm exam, but yeah, I don't know whether I'm going to do that. So most of what we care about here are negative negative externalities. All right, so how do you, so just as a, to see if you sort of see where we're going. So how should we correct for positive and negative externalities? No ideas? So I'm going to give you an example of externality. So a car emits CO2 because of it uses gasoline. So what do we as a society do to mitigate this externality?
I guess we build electric cars. I don't know what a good example of that would be.
Yeah, so what we want is to correct people's behavior. So let me go back to this this example here. So what's going on here is that there's an external cost. So this is so imagine that the market equilibrium is what people, how much cars they would buy and how polluting the cars would be. And then there's this marginal external cost there. So what we would like is to reduce the quantity and increase the market price of the good so that people buy less of it. So what we want, so you're saying we should use more electric cars, yes, but so here what we're going after is some market solution, market-based solution, by which I mean something that would change people's behavior. So I'm not going to mandate to write a law that says in 1 month, all Canadians must have bought electric vehicles. So how should I encourage people to switch from electric to, or switch from gas to electric? All right, I have answers now. Yes, raise gas prices. So how do I, as a government, raise gas prices? Yes, exactly, tax. And I've seen somebody who suggested subsidies. Yes, subsidies for electric cars is a good one. Although, I don't know if I told you that, but yeah, a student last semester did a wonderful work on the subsidies for electric cars in Quebec and Canada in general. and said that they were way too high. And essentially, what's going on is that if you take some value of damage that's caused by a ton of greenhouse gases or CO2, which is around what economists say, so $30, or you could even go to $50 per USD per ton. So it's way below the cost that the government or the subsidy that government pays to buy electric cars, because electric cars, they don't save all that much from compared to a very fuel efficient gas car. Fuel efficient gas cars, they are cheap to produce. So the thing you have to take into account is the fact that it takes energy to make the batteries and build all these cars. So from a life cycles perspective of how long you plan on using the car, there is electric car, yes, does emit a bit less, but the difference isn't all that much. And the size of the subsidy that we actually give is well, I can't say that I have checked all the numbers perfectly in his work, but from reading it, it looks really hard to go against it. So yeah. So, but it's true that anyways, subsidies can be good, but yeah, taxes are good instruments too. So here's how we can correct for externalities. So taxes and subsidies are called Pigouvian taxes and Pigouvian subsidies, from an economist named Pigou from the beginning of the 20th century, who started talking about the fact that we could use them. Quotas or other mechanisms, tradable permits, these are more or less the same, as we're going to see. These are the best, the things that are most popular among economists. Yeah, Pablo?
Yes, sir. I was just wondering, would the cohesion theorem be within the ones for correct an externality?
Cost theorem.
Yeah, the cohesion theorem.
Yeah, yes. We're going to discuss it at length. But
Okay. Would it be for negative externalities or positive ones?
Yeah, both.
Okay.
Yeah, I would say for positive externalities too. So think about the example I gave last time. So if I'm producing honey and my bees help the farmer next door, and then the farmer can simply come to tell me, oh, please, wouldn't you mind producing more honey? I can pay you a bit. So to help you have more bees, so because that helps me, and it's possible to negotiate. So actually, I would say that's a super easy case of just neighbors helping each other. So that would be a very, very easy case for applying the cost theorem. Actually, it's more complicated when you have negative externalities, because then you say, oh, please, you're annoying me, stop doing what you're doing. And then, oh, no, I won't. And then you have fights between neighbors, and that's complicated.
Yeah, for sure. Okay, thank you.
So yeah, perfect. Awesome. Okay, so public goods, let's go to, so what are public goods? They are similar to externalities in the sense that, so if I could, for instance, build a park for myself, so that's my good, but then if other people can enjoy the park, then it's a sort of super big externality that I give to all the people in my town. So the concept is more or less the same, but we differentiate between public goods and externalities because yeah, they sort of deal with different types of problems, but yeah, the two are similar. So we generally classify public goods according to two criteria. So first of all, arrivality, and second of all, excludability. So what we mean by, and what we say is that public goods are typically non-rival, by which we mean that contrary to private goods. So if I go and say buy a salad or a chicken and I eat it, well, that's very sad. But once I have used it for my own personal consumption, it is gone, and my neighbor cannot use it. But that's the nice property of public goods, is that if I'm using a park, then I stop using it, then the park is still there, and it's perfectly useful for other people to be using as well. So that's the property of non-rivality. So you could think of air. So if you breathe air, there is plenty of for me and plenty of for you, and we can all share in happiness and have everybody has air. So radio station. So if I'm listening to a radio station, the radio waves are just out there, and anybody can tune in and catch the next song on the radio. For young people, radio used to be something that some medium some electromagnetic waves that we use to send signals and listen to radio. But I know that nowadays it's everything is on the internet. But in a way, it's kind of the same. So if I look at some website, then it doesn't prevent somebody else up to some limit of having a super high traffic. So it shouldn't prevent somebody else from accessing the website. And then non-excludability. So is it possible to exclude people from using the good or not? And usually we say that public goods are non-excludable. So it's very hard to prevent people from using them. So again, air. So I can breathe air for free, and I would be hard pushed to prevent other people from bringing the free air around us. Or watching fireworks, for instance, you may try to get people to pay for fireworks, but since they're high in the sky, then it's quite easy to share them and to not pay for them. All right, so usually we combine these two characteristics. So we have so for instance we have excludable and rival goods, which are just normal goods. So like any consumption good, like clothes or whatever. So could somebody give me an example of non-excludable good, but rival good? So a good that for which it's difficult to exclude people, but if somebody starts consuming it, then it prevents other people from consuming it.
A bathroom.
A bathroom? Yeah, well, I can lock the door. Oh, yes. Yeah, so I can exclude people from using the bathroom.
I'm going to watch a hockey game. Would that make any sense? Because it's for everyone to go see, but if you buy the ticket, then right.
So watching the hockey game, yeah. All right, maybe it's too theoretical. I'm going to go to what the next slide. I wanted to just make you think a bit about it, but yeah, here we go. So this is how we usually classify them. So we use the two criteria above. So is a good rival or non-rival, excludable or non-excludable. So rival and excludable, we see there are pure private goods, like any consumption good or food or clothing or housing. Then rival, but non-excludable. So what are they? They are, so we see they are common goods. So a good example is common pool of resources. So fishing grounds, groundwater, free parking spaces. So what happens is it's there, so it's very hard for somebody to, especially internet. So if you think about fishing grounds, so on international waters, anybody can go can go and try to catch like tuna or whales or whatever. It's very hard to prevent them. But once they're caught, then it's so there's less of it for other people. Same with groundwater. Same with parking spaces. So once I park there, so there's no fence preventing me from parking there. But then once my car is there, then your car cannot be there. Then on the other end, you have club goods, which are excludable and non-rival. So club goods are something like cable TV, or you could say like Netflix. Like cinemas, like private parks. Oh, private parks, yeah. So they must be private, right? You must be able to build a fence around them to prevent people from going there. And then really pure public goods or real public goods are public goods that for which you cannot exclude people, and the fact that they're there don't prevent other people from using them. So the atmosphere, sunlight, environmental quality, knowledge, art. So yeah, any intellectual production is pure public good. So yeah, so formulas, ideas, science. Those are all because once they're there, then it's hard to prevent people from using them. And of course, what you can do is encourage people to. So you may want the problem is if you cannot prevent people from using them, then so take vaccines for example. So it takes a lot of effort to design a new vaccine for COVID-19. So how do you motivate companies to spend a lot of money on them if anybody can then, or any country can then take their formula and or take their process and copy it and do it for a fraction of the price that they would want to sell it. So then we need some way to motivate people. So then we need some solutions for this. Otherwise, they are what we may say they are underproduced. So it doesn't make sense for people to produce a better environmental quality because anyways people are not going to pay for it, or art or knowledge or formula, once it's out there and anybody can take advantage of it, then it means that as the creators, they don't really get any incentive. So what are the incentives that we can use to encourage people to produce public goods? No idea.
Make them free or bring down the costs to use public goods.
Yeah, so I'm saying that this is the problem. The problem is that once I invent, so once an idea is out there, then it's sort of, so it means that the person who came up with it, and maybe that person needed 2 years to think about it. But then once it comes out, then everybody can have it for free without paying. So the person who did produce it can't take advantage of it. So then there's no incentive for people to produce it in the first place.
And that's why we have patents, right?
Yes. That's what I was after. So patents. Yeah, so you have yeah, for art, you have yeah, licenses, or yeah. So what license? So you have yeah, rights, copyrights. And so economists are thinking about this. So what are the optimal ways of, what are the optimal length of copyrights, for instance, or licenses? And so just as a basic idea, so what do these things have in common? Well, they give monopoly to people. So then people can choose however they want to charge for their production, their invention. So essentially, these things make pure public good, club good. So it allows people to sort of say, oh, now it's not like anybody can access it. Now you have to pay to be part of it. So it goes in here. So shifts, yeah. So make pure public good, club goods. Yeah, I would say excludable. Make, oh yeah, non-excludable goods. Excludable. And if you think about club goods now, what may be the problem which make them, yeah, what could be the problem with them or the limitations? I could think of two, but yeah, one is not that bad. But
For club goods, I guess one of them could be that the limitation is, certain people can buy, or certain people have access, right? You're targeting a certain audience in a way. I don't know if that makes any sense, right? I mean, I'll give an example. Here it's written cinemas, right? So you have to pay to get in,
yeah,
right? So in the lower class people necessarily won't be willing to pay $40 to go watch a movie and buy some popcorn, right? Compared to the middle class who's maybe a bit more willing.
yeah. So you're saying it's too expensive.
Yeah.
So you should have, well, so if I build my own cinema, then what I should have is cheap seats that are good, and then that are bad. So like front row seats or back of the room seats, and more expensive seats in the middle. So I think it's yeah, what you have in mind is yeah, it's definitely something that they should have to think about. But yeah, they have different seats that can cost a different price. So for concerts, for instance, or hockey games. But so in this context, what can go wrong with public good that with club good that can make them say fail? Yeah. So what I had in mind is piracy or cheating. And what does this thing do? So it changes, yeah, makes, you make excludable good. Non-excludable. So that's the opposite. So yeah, so really club good, it's the least problematic of type of public good. It's almost like pure private goods, in a sense that it's just it's some good that can be enjoyed by a larger number of people than pure private goods. But you just have to make a fence around it and say, okay, I allow 50 people to come and enjoy this good in common. It may be cinemas or cable TV like Netflix. And so there's no problem. Really. Netflix will produce their series, and they will get paid for that. So they will have incentive to produce more. So it's really not problematic. So in a sense, non-rivality isn't that big a deal. Non-excludability is the real problem there. That's what creates all the issue with common resources that are not protected enough, or pure public good that are not generated enough. Right. Oops. So just going into more detail. So what we mean here. So common good, like open access resources. So the access is uncontrolled. There are no property rights. So example, the ocean, the air, public lands, forests, where anyone can go and cut wood, for instance. So if you don't have rules, then just everybody's going to cut wood, and what you get is what you get in Amazonia, for instance. If nobody owns the Amazonian forest, then nobody can say that you're not you're prevented from cutting the woods there. So people just go and cut wood. So there's overuse and abuse, and there's a famous article is called "The Tragedy of the Common" by Garrett Hardin. Also, there's but the idea is older than that. So yeah, he was in I think it's 1969. Yeah, this is 1969. But the original idea was by William Foster Lloyd. Yeah, it's a British economist. Yeah, so of course, these ideas are not new. People have realized that there's a problem with open access. And so people say that that was one of the steps that made England the modern country that it is, that before you had everybody could use the fields everywhere. And at some point, people started putting up fences everywhere. And this sort of created private property and private ownership and the contract and all of the modern institutions that we have now. So I'm not saying that's the only way to create a value, but that was some big event in England back, I don't know, in the 19th century maybe, or 18th century. All right, so what's wrong with open access resources and non-excludability? Excludability is free riders. So free riders are people who just take advantage of something and do not pay for it. So I'm thinking not of myself. I've never downloaded anything illegally. I've always paid full price for everything. In terms of modeling, what you would say is that you don't pay at your full marginal willingness to pay for a good. So you pay zero, but you would be willing to pay more for something. So it means that essentially the market price is not going to reflect the total willingness to pay of everybody involved. Yeah. Public park is another example. So if a town wants a public park, but then you ask people how much they want to contribute to the public park. So some people say, oh yeah, I don't really want to contribute all that much. But yeah, so maybe, I don't know if you remember this story I told you, maybe about yeah, problem about asking people for their willingness to contribute for public goods. Is that the answer strategically? So it doesn't mean that we never do it. We try and still ask people whether they would like certain thing or not and get some answer, but yeah, these answers are not perfect. And to really decide how large a good should be, well, you need to ask for people's happiness or willing to pay for any quantity that you would build. So you would say, oh, would you be willing to have a park that's this large in your neighborhood? How about this large? How about this large? So you see that it's very complicated, very hard to extract the good information about it. Yeah, so problem is people think that they don't want to contribute individually, the other people will contribute. So, and by the way, Adam Smith is well known for his description of the free market equilibrium, but he also described at length the problem of the public provision of private good. And he basically said that the states should have taxes that levy money to contribute for public goods. Yeah. Yeah, so public goods are underprovided in the free market. Their non-excludability makes it hard to prevent free riders. So yeah, that's a bit the same as I was saying. Yeah, so policies may be used to address the issue, but they're not necessarily easy to apply. Yeah, I think I've some redundant information in my slides. Sorry about that. Yeah, so how do we model public goods? So it's going to be different than public goods than private goods for two reasons. First of all, so private goods, once I consume it, it's unavailable for the next person. So it's rival. So it means that if I want to supply a certain amount of private good as a firm, then I'm going to supply some of it to the first person and some of it to the second person. So this is why we add the quantities that are consumed by each person. We add them all together. So we add quantities, and the benefit I get from consuming the private good is my own benefit. So we don't add the benefits together. So public good is completely the reverse. Once a certain quantity is produced, it's available for everybody. But the fact that it's available to everybody means that if I want to know how much public good to produce, I should actually add up all the people's willingness to pay together. Yeah, so this is what we get. Rather than having horizontal summation, we have vertical summation of marginal willingness to pay. So this is I would say it's the only case in which you are going to add the marginal willingness to pay vertically instead of horizontally. So let me show an example of this. It's okay. Yeah, it's there. Yeah, okay, nothing is missing. So let's go back to Alice and Bob. So Alice has her marginal willingness to pay is 2 minus Q. And we're going to say that. So what happens is if Q is higher than 2, so you would, if Q equals 3, for instance, then you get 2 minus 3 equals -1. But yeah, you don't say that the marginal willingness to pay becomes negative. It's just 0. So that's what I'm writing here. Marginal willingness to pay for Alice is 0 if Q is greater than 2. And then you have Bob, who has a higher marginal willingness to pay for some goods. So here, Bob would benefit more from having this this good for himself. So he would be for a very, very small quantity, Bob would be willing to pay as high as 3. But then it decreases as you increase the size of the public good, and it reaches 0 when Q is at 3 or bigger than 3. So then how do we aggregate these? Well, let me show you how that will look like. So you have Alice here, MWTP is 2 minus Q. So this is Q, 2, and yeah, so this is how you draw it. And then you have Bob, which has 3 minus Q as a marginal willingness to pay. And then we said that if it's a private good, you add them horizontally. Here you add them vertically, because what you have to account is the fact that if I produce 1 unit of the good, it creates a benefit of 2 for Bob. So that the benefit for Bob is his marginal willingness to pay, and plus a benefit of 1 for Alice. So the total benefit of producing 1. So I can show, for instance, very precise. Yeah, so the total, the marginal willingness to pay in aggregate of the whole society is the sum of 1 plus 2. So that would be 3 here. All right. And then we get kinks. So we get kinks like previously, but we don't get kinks because of different prices. We get kinks because here after 2, Alice's marginal willingness to pay is 0. So then after 2, you only get Bob, who's still willing to pay for some good. So that's why you are going to get this right there. All right.
Sir, I have a question.
Yeah, go ahead.
For the aggregate chart. So the first equation is basically a summation of Alice and Bob, right? That's what I'm understanding.
Yeah, so I just jumped from when I said Bob, I jumped to the graph to show you what's going on, but I'm going back there.
Okay.
Yeah. So so just to show, so that you understand what's going on. So between 0 and 2, so there's so to get the total or the aggregate marginal willingness to pay, you add Alice's and Bob's marginal willingness to pay. So this is what I write here. So between 0 and 2, so Q between 0 and 2, you the aggregate benefit or aggregate marginal willingness to pay is that of Alice plus Bob. So it's so that's 2 plus 3, that's 5 minus Q minus Q, so 5 minus 2Q. So again, if Q is between 0 and 2. And then for Q between 2 and 3, you get the marginal willingness to pay of Bob, which is 3 minus Q. So you get 3 minus Q between 2 and 3. And then it's 0 for Q is greater than or equal to 3, because after that, nobody wants to pay for it. So this is 5 minus 2Q until here. And then after here, it's 3 minus Q. And then after 3, it's 0. All right. So of course, I'm going to give you an exercise to practice this afterward. Okay, so do I need to explain again, go back? Now is the time if you like me to do that. Oh, by the way, No, that's all right. Okay, so if it's all right, let's continue. So just to summarize what we just did there. So the aggregate demand for public good should be the aggregation of individuals' demand curves or for private good. And we do this. Oh, yeah. Sorry, I thought I just said it's vertical and then it's horizontal, but yeah, it's for private good. So for private good, you do a horizontal summation. So you add up quantities desired for a given item. But then for a public good, what you do is you add up, you do a vertical summation. So you add up individuals' demand vertically. So for a given quantity of the good, you add up each person's willingness to pay. All right. This is because of their joint consumption of the good. So rather than the good being consumed by one person and then the other has to consume some other units, the same units are being consumed by two people, and thus they produce benefit from the two people at the same time. So, yeah, let me get rid of this. So this is what's going on. So efficient provision of public goods. So yeah, environmental quality, of course, or environmental improvements is public good because it's enjoyed by everybody that's affected by it. So if you take the example of greenhouse gases, so not having a world that's too warm is something that's beneficial for most people in the world. Maybe not. I don't know if yeah, it's having a warmer planet may be beneficial for some people, but I'm pretty sure people in the near the equator are not. And still, people, I think even somewhere like Quebec would be like the least affected place, maybe, or Russia. But still, it's there's going to be at least disturbances in terms of yeah, agriculture and stuff like that. So the transition between the world in 1950 and the world in 2100, for instance, will be chaotic, to say the least, for farmers, even in Quebec, for instance. Yeah, so you would really say that yeah, environmental quality improvements is beneficial for everybody. Yeah, so each consumer must be charged his or her willingness to pay for the good to achieve an equilibrium where demand equals supply. Yeah. Yeah, so efficient allocation of public goods is determined by the intersection of the market demand curve and the marginal cost curve. So this is just yeah, what you need to find. So we're going to have the real model for pollution, which is going to be the marginal abatement cost and marginal damage model. We're going to see this. I think it's the next chapter. Yeah. So once the quantity of the good has been determined, the individual demand reveals the efficient price that must be charged to each individual. We cannot use the market demand to determine the uniform price for all consumers. Yeah. Oh, this is where I was going. So, oh yeah, so last slide. So efficient pricing requires that if a different price be charged to each consumer. So that's the problem with public goods. So consumers don't necessarily reveal their willingness to pay. So for instance, the TV in Denmark, and even if the true willingness to pay is revealed, charging different prices to different people is not easily applicable. So you would have to ask people how much are you personally willing to pay for 1 unit, 2 units, 3 units. So that's quite complicated. So this is a summary of what's wrong with private good, with public goods. All right, and there you have some exercises. So a negative externality. So if, for instance, if the inverse demand of a market is P of Q is equal to 8 minus Q, the supply is MPC, a marginal private cost of Q equals Q. Then find the competitive equilibrium, find the socially Is there something fishy about my exercises? Yeah, it's like if I didn't give you the, okay, I check again my exercises there. It seems that you're missing some stuff. And then there's yeah, okay, so I'll post that when I post the slides, I'll post the correct ones. Make sure that the exercise is doable. And then I'll give you some time to think about it. Now I just want to, so we still have a bit of time. 15 minutes. So I want to go back to the exercises I posted previously. So okay. So this, we already did that. So have you looked at them? Have you tried? So who has tried? Yeah, that's what I was thinking. All right, so let's do them. So Alice likes oranges. So this is last chapter. Alice likes oranges. Bob, not so much. The marginal cost is MC of Q equals 2Q. Find the inverse demand of Alice and Bob. So I think this we already did. But anyways, I want to do that with you. So here's what we're going to do. We're just going to have some, how should I do that? Yeah, I want to draw stuff. So yeah, let's just create some white page there. So if I had a board, that would be much easier. Okay, here are the exercises. Find the inverse demand of Alice and Bob. How should I do that? No idea. Okay, maybe I'm going to call on some people if nobody wants to sacrifice themselves. So let's see. All right, let's ask Claudia Lopez. So Miss Lopez, how should I find the inverse demand of Alice and Bob? Are you with us? So these exercises, I put them there to help you, right? I could just move on with the rest of the material, but I think it's, oh, we have a solution. All right. Thank you, Mathieu. So saved by Mathieu, you should thank him later. All right, so how we do that? Well, you just remove the P there. So what you say is QA equals 8 minus P divided by 2. And then you just put 2 in front of here. So you say that this is equal to Q to A minus QA. So and then we can multiply by 2. So we get 16. And then minus 2 times this, right? So that's 1. And then same for the second one. So QB equals 4 minus P. So that would be PA, yeah. So P equals 4 minus QB. So that would be P of Q, PB of Q equals 4 minus Q. So this is how we find the inverse supply. So thank you, Mathieu. Questions about this? So you should be familiar with this. It's going to be very useful for you afterward. What is the total willingness to pay of Alice for 4 oranges? So I'll leave you. We have suggestions, so let's try it. So I'm just going to draw stuff so we can see what's going on. So of course, it's this is very useful because then we can draw them with price on the vertical axis and quantity on the horizontal axis. So it's 16 minus 2Q. Imagine this is 16. And then this would be yeah, something like that. So to know what the number is here, I have to ask if PA is 0, what is Q? So I get that 0 equals to 16 minus 2Q. So two Q equals 16. So Q equals 8. So this is how I find this value here, which is 8. So this is PFU. And then I'm asking what is the total willingness to pay of Alice for 4 oranges. So at 4, I get, I could be willing to, I could be computing it, but I'm going to be able to see what's going on just by looking at it. So it's this oval shape there. So this is 16. So number 2, that is total willingness to pay Alice for 4 is 16 plus 8. This will be 8 times 4 divided by 2 equals, and then people have said, yeah, 48. Nice. So yeah, 16 plus 8, that's 30, that's 24. So yeah, times 248. All right. 3. So now things are getting more interesting. Find the aggregate demand. What should I do? I'll let you think for 1 minute. PD equals PS. Yes, so which one? Should I add the quantities or the prices? Are we in a public or private good now? So we are chapter 3, that's private good. So private good. We add the quantities horizontal. Yeah, so we don't add the inverse demand, we add the demands. All right, so I won't have time to do it, but I definitely want to finish this exercise, because if you don't practice or if you don't see what we're doing, then it's going to be harder for you at the exam, right? So yeah, think about it, and we can continue next time. And next time is Monday, and it's in person. All right, so one last question before we go. Okay, so have a nice end of your day.